V same RT divide V minus B minus A divide V2, where is a positive constant directly proportional to the energy of vaporization of the liquid. Two things should be noted about the introduction of the A divide V2 term first port. So that example, we have a box, and box we have molecules. This is a B2, then B1, acting on any volume element in the interior of the gas balance or to zero only those elements of volume near that wall of the container experience an unbalanced force that tend to pull them toward the center. Thus, the effect of the extravertic forces is felt only in the walls of the vessel. Second, the definition assumes of the affecting the range of action of the extractive force of the order of centimeter in peaks. The range of these forces is of the order of extracting forces of the it is at the nanometer. In the chapter 29, we do the derivation without this assumption and obtain the same result. Equation is the van der Waals equation proposed by van der Waals, who was the first recognized the influence of molecular size and intermolecular force of the pressure of a gas. The sweep force of attraction are called van der Waals force, the van der Waals constant, and A and B for a few gases are given in the table. The van der Waals equation is frequently written in the equivalent but less instructive forms, and V plus A divide V2 and V minus B same RT, or V plus n quadrat A per V quadrat and V mean and V same in RT, where B same and V has been used. This has been used in the second writing. Implication of the van der Waals equation. The van der Waals equation takes two effects into account. The first is the effect of molecular size, and V RT divide V mean V. Since the denomination in the above equation is smaller than the denominator in the ideal gas equation, the size effect by itself increases the pressure above the ideal value. According to this equation, it is the empty space between the molecules, the free volume that follow the ideal gas law. Second, the effect intermolecular. This is molecular, and this is intermolecular, and V same RT divide V mean mean A divide V quadrat. This is in intermolecular. Account the effect attractive force by itself reduce the pressure below the right, and is taken into account by separating a term for the pressure and calculate Z for the van der Waals gas. We multiply equation by V and divide by V divide and A this year, and z and same phi v divide rt mean v divide v mean a divide rt v. The numerator and denominator of the first term of the right hand side are divided by v, and z 1 plus v mean a divide rt, and 1 divide v plus v divide v quadrat plus v divide v uh, v divide v cubic and etc., which expresses that at a function temperature and molar column, it would be preferable to have z and a function of the temperature and pressure. However, this were until solving the Panderson equation for v as a function of t and v, the multiplying the result by phi divide rt to obtain the z as a function of t and p, since the Panderson equation is a cubic equation in v. The solutions are too complicated to be particular and informative. We content ourselves with approximate experience for z, and then z into t and phi, which we obtain from equal by observing that as p naught and phi same 0, and this expression of the current of the term is p2, and then when the z same 1 and z, so that we have z 1 plus 1 divide rt, and v mean a rt, and v, and then plus a divide rt cubic, and 2b mean a divide rt and v2 and etc. The correct coefficient for v could have been obtained by simply replacing 1 divided v by the ideal value is equation. However, this would yield incorrect value of the coefficient of the higher powers of pressure equation, so that the term reversible for non-ideal behavior vanishes not only as the pressure approaches 0 but also as the temperature approaches infinity. Thus, as a general rule, real gases are more nearly ideal when the pressure is lower and the temperature is higher. The second term of the right of equation should be compared with the second term of the right of equation, which consider only the effect of infinite molecular volume. The slope of the z versus b cubed obtained by differentiating with the respect of pressure and keeping of temperature constant. The law of corresponding stage using the value of a, v, and r given by equation, we can write the van der Waals equation in the equivalent form, and then v same 8v v and t divide 3t and phi minus phi 0 for 3 and minus 3 phi quadrat per divide phi quadrat, which can we rearrange the form, and then phi divide v1 and 8 t for t1 and divide 3 V divide V1 and minus 3 and minus 1 and minus 3 divide V for V1 quadrat. Equation involved is only the relation V and T divide T and V divide V. This suggests the this relation rather than V, T, and V are significant variables of the characteristics of the gas. This relation of call it the reduced variable of states rho V tau and key and V same V divide V and tau and T divide T and where return is the term of these variables in the van der Waals equation, so that V and 8T for 3 and Q and mean 1 and 3 per cube 2. The important thing about equation is that it does not contain any constants that are particular and individual gas. Therefore, it should be capable of describing all gases. In this way, the laws generally enter the using of van der Waals equation compared with the ideal gas equation. Its Regen equation, such as with experience one of the reduced variable of a function of the other two reduced variables experience of the law of the corresponding states of the gases at the same reduced temperature and under the same reduced pressure are in the corresponding states. By the law of the corresponding states, the salt bulk a coffee the same reduced volume. For example, we have argon. We have argon at T same 302 Kelvin, and under we have V and 16 atm freezer, and we have T2 H5 same 381 Kelvin, and under we have V, this is T, and V we have 18 atm. Are its corresponding states, since H has tau, we have tau and 2, and we have tau and V 1 divide 3. An equation of states the infallibles and little constant in the addition to R can be written in the term of the reduced variables only. For its reason, equation that involve more than two constants were at one time found a given the contradicting is the low corresponding states at the same time. However, the equation to constant equation could be divided to represent the experimental data. This helps we have been abandoned in this recognize that the experimental data do not support the law of corresponding states as a law of grid accuracy over all range of pressure and temperature. Although the law is not exist, it has a good deal of importance in engineering practice in the range of the industrial pressure and temperature. The law of the Hall with Aquarius substance of the engineering calculation float or Z versus V divide V at various reduced temperature are ordinarily used rather than an equation.